Okay. Interesting. Give me Oh man. I guess I didn't label the day. No, that's not right. Pneumonia. There it is. Okay, marginal zones in the spleen are where marginal zone B cells congregate. Yep. Okay, again, innate immunity is immediate, not specific, and it has no memory, while adaptive immunity is delayed, does have specificity, and does have memory. Okay. Barriers. We've got the first line of defense, so mouth, epithelium, mucus secretion, ears, nose, eyes. Most organisms can't go through the intact skin because you've got a layer of dead skin on your skin. It's called the stratum corneum. Yeah. Your upper skin layer is dead and will constantly desquamate. I think that's how you say that, which basically means it's just generating new skin and it's coming off skin cells. Most dust is dead skin. That's just the fact of life. Separates inside from outside. Yep, mucosa of the respiratory tract is defended by hair, turbinate, cilia, mucus, coughing, sneezing. Then you've got the alimentary tract, which is like digestive. That's saliva, an acidic pH, bile. And then reproductive urinary tracts, reproductive/urinary tracts are defended by an acidic pH and urination. I mean, literally. That's what it is. Now the microbiome, you've also got a microbiome on your skin, in your gut, everywhere in your body. You've got an eye microbiome. You've got a mouth microbiome. You've got a nose. It's true. And these microflora can also defend against pathogens and foreign materials. Yep. You can get infections all over the body. Pneumonia, that's common. That's the lungs. Pneuma, meaning lungs. Onia probably means something to do with disease. But pneuma, Pneuma, is the Latin root word for lungs. And then, oh man, I wish I could show this picture. So in your nose, you've got it looks like a butterfly. It's called turbinate area. It's like very windy patterns in your nose that also help to defend against pathogens and stuff. You got to be careful though with your immune system is very important because a cut on your finger literally goes straight to your heart. Think about it. Your circulatory system, the capillaries that send blood to the tip of my finger, those also have veins that take that blood back all the way to the heart. So a pathogen could just ride that blood all the way to the heart, cause really bad problems. Sentinel cells, these are things like mast cells, dendritic cells, tissue-resident macrophages, like Langerhans cells in the skin. They're scattered throughout the body, mostly just below body surfaces. Hi. And They are equipped with multiple diverse pattern recognition receptors, all to detect threats. These are things like MAMPs or DAMPs. MAMP being microbial associated molecular patterns, and DAMPs being damage associated molecular patterns. I'm doing okay. How about you? Just studying for vet school right now. Okay, and then we have epithelial cells, endothelial cells, fibroblasts, keratinocytes. These can also act as sentinel cells under certain circumstances, but they're limited in their duties because they don't have as many PRRs, pattern recognition receptors. And yeah, most components of the innate immune system response are found in the blood. These are things like neutrophils, right? Eosinophils. I am studying for, right now, immunology, and I'm in vet school. So this is veterinary immunology. I agree. I thought of this way of studying. Well, I'm probably not the first person to think about it, but I was like, if I record myself just going over my notes one more time, maybe it would help me, and it could help other people too. Maybe they'd learn something that they could apply for their animals. I don't know. And this also forces me to, do something, and I get to talk to you guys, so it's pretty cool. Okay, macrophages. Unfortunately, I don't think I can show these materials because, one, they're technically not mine. I didn't come up with them. Two, they're copyrighted. That kind of goes with number one. And, well, these are all kind of a result of each other. It's illegal. That's the point. I can't show you them. But I think if I talk about it, fly buzzing around. I don't think it's... Can I do a room tour? I guess it's not really. This is my studying room. It's kind of just bare. There's a futon couch sort of thing. There's a door, empty closet. Thank you. I'll try to study hard. Man, this fly keeps buzzing around. Anyway, yeah, we had a roommate that used to live in this room, and he moved out, so I was in the other room, sleeping in there. My brother and I have our beds in there. We were trying to cut down on rent, and it worked. We had pretty cheap rent. It was like $230 a month or so for a while. Now it's $350 for the two. No, $370. I don't know. It's gotten more expensive. What am I doing? I am studying for vet school, veterinary immunology. That's what I'm doing. Anyway, back to that. We have lipoproteins or flagellin. These are all things that pattern recognition receptors can detect in foreign particles, like microbes. Because our cells, or your pet's cells, don't have flagella. They don't get around like that. They don't have, well, I mean, there's different kinds of lipoproteins, but they don't have lipopolysaccharide. That's what LPS is. Okay, and then we have physical barriers. Here's a question. Why are the components of the innate immune response, why are they found in the blood? Well, let's think about it. So, the blood literally goes everywhere in the body, doesn't it? It goes to your fingertips, it goes to your nose, it goes to your head, your brain, it goes to your mouth, it goes to your neck, it goes to everywhere. It's the circulatory system. And so it makes sense to have the immune system in the circulatory system. White blood cells mingled with that helps with defense. Like if I get a cut on my finger, guess what? Blood. And guess what's in that blood? Innate immune particles. Thank you. I appreciate the compliment. Then we have, yeah, most of them are found in the blood. Yep, already talked about that. But how do they get out of the blood vessel? Well, I think I'll talk about that a little bit later as well. But neutrophils are one example. What they do is they tether to the blood vessel surface, the edge. You know, you've got a vessel, right? It's like a tube. This is way bigger than our blood vessels are. But you've got a tube. You've got the blood flowing through the tube in your body. And guess what else is flowing in there? Neutrophils. What they do is if there's like cytokines and chemokines that attract this neutrophil, and so they're like, oh, there's something down there I got to get. And so what they do is they tether to the wall of the blood vessel, then they roll along it, and then they activate, and this causes them to adhere to the blood vessel wall. And then they do something called transmigration, which they literally go through the blood vessel wall. And then chemotaxis is where they go attack the bacteria or whatever it is that is foreign. Okay, and that's all for immunology. Onward to anatomy again. Yeah, that's the last one, anatomy. Okay. Last one for the day. 29. Yep, okay, here we go. Nerves of the thoracic limb. So, again, I already took the exam for this, so I don't really need to know this anymore. I mean, I need to know, like, the general concepts, but... oh, man. Yeah, anatomy's crazy. All right. So, in the spinal cord, there's something kind of interesting that goes on near the limbs. Okay, from C6 to T2, that's cervical vertebrae 6 to thoracic vertebrae 2, and from L4 to S1, which is lumbar vertebrae 4 to sacral vertebrae 1, we've got places where the spinal cord is like running like this, and then it's like this at that spot. Not this exaggerated, but then, okay, then it's line again. Then it's very thin. So it's thin, then it gets thicker, and then it's thin again. Why? Why would it do that? Why would it do that at the limbs? Well, I kind of just answered it there, didn't I? It's because it's at the limbs. You've got to have some nerves going down to all these limbs, right? So you've got the spinal cord going down the body, and then right about here, there's a bit of a bunch because it's got to branch off. So you've got to have more neurons going into each of the limbs. And it's the same for the bottom limbs as well. And yeah, it kind of just, those are bulging spots. I don't even know, well, I probably didn't even know that, but anyway. Brachial plexus, that's where the nerves start off. Yeah, the spinal cord doesn't start at the forehead. I know that. I'm just I'm just, I don't know. I don't know. I was, what's the word? I was visualizing it, trying to make it make sense. Yeah, the brain is in here. Spinal cord comes off the brain, right? Yeah, and then, yeah. Yep, central nervous system, CNS. Okay, brachial plexus. Uh, so what is a plexus? A plexus is a network of anastomosing or interlacing blood vessels or nerves, or an interwoven combination of parts of elements in a structure or system. So you can have a plexus in anatomy, or the plexus of knowledge that I have to know for vet school. That's another way you could use that word, I guess. Okay, I learned all this at some point, but I don't need to know most of it now. The radial nerve is involved with extensors of the elbow, carpus, and digits. And usually there's only one innervation for a muscle. That's different. Thank you. I appreciate the encouragement. The difference between nerves and arteries, other than their action, of course, is that there's multiple arteries that can fuel a particular tissue. For example, the bicipital artery can give blood to the biceps brachii, the brachialis, and the coracobrachialis, but so can the cranial circumflex humeral artery, and so can the transverse cubital artery. And there's probably more. Okay. There's both a superficial and a deep branch of the radial nerve. The superficial branch is involved with sensory input, or sensory function, I guess. And the deep nerve is involved in motor actions. Like it moves the muscles, whereas the sensory nerve, you feel stuff with those nerves. Yeah. Differences. Okay. Yeah, those are called autonomous zones. Wow. Radial nerve paralysis. Yeah, these are all just a bunch of problems that can happen. Afferent is into, efferent is out of, exiting. Think of efferent, E for exit. Okay, lymph nodes, important, yep. Lymphatic system, yep. Okay, good. That's pretty much it for August 29th. Again, I've got a lot of catching up to do. I've got like 18 days or so. No, 12 or so. There was a couple weekends in between there. But anyway, I'll hopefully be back tomorrow. Hopefully I can knock these out in the morning. So I try to wake up at like 4 a.m. and do them after that, after I wake up. And get them knocked out so I don't have to worry about them later. 2 a day until I get caught up. Then it's going to be 1 a day, hopefully. Yeah. Okay, thanks for watching. Appreciate y'all. And maybe I'll see you in the next one.